And this is the problem with recording it on my phone. This is a phone calls coming in. But there could be some covalent interaction here. When we're dealing with heavy metals like silver, lead, mercury, we always have to worry about covalent interactions. So for example, lead 2 chloride is pretty ionic, but lead 4 chloride is covalent. In fact, lead 4 chloride forms molecules of PbCl4, whereas lead 2 chloride forms an ionic lattice. The ionic lattice has these ions packed together in a 3-dimensional array. Right? Lead 4 chloride is soluble in water. Lead 2 chloride is insoluble. And so there's quite a bit of covalent interaction happening here. And so with the heavy metals, we got some covalent participation in the bonds. And so the bonding is a little bit more tricky. And so we can't just assume ionic. If this were 100% ionic, then PbCl2 should have a stronger bond. PbCl2 has a stronger bond, it's more stable, right? But I always worry about these heavy metals because of this, the covalent interaction. And so to answer this point, what we could do is we could look it up. So rather than going to the CRC Handbook of Chemistry and Physics, Wikipedia is pretty good with this data here. These are physical properties. So if we look at the solubility in water, let's look at the solubility at 20 degrees C. We can get 0.0756 grams of PbI2 to dissolve in 100 milliliters. So remember that, 0.0756 grams per 100 milliliters for PbI2. Lead 2 iodide. Okay, let's look at PbCl2. For PbCl2, we could get 10.8 grams in a liter. So 10.8 grams in a liter, well, for 100 milliliters, we just move the decimal. And so PbCl2, we can put 1.08 grams per 100 milliliters. So which one's more soluble? PbI2 or PbCl2? It turns out that PbCl2 is more soluble than PbCl2. So does that mean our thinking is wrong in terms of this lattice energy and ionic bonds? Not necessarily, because we're making a faulty assumption. The assumption we're making is it's 100% ionic. Well, it probably isn't 100% ionic. And so, well, that's one way to left it. Whatever theory we have has to agree with experimental fact. And so we have to refine or come up with a more detailed picture of the bonding in PbCl2 versus the bonding in PbI2, or have a better understanding of what increases or decreases the solubility of this particular species in water. So this is metathesis. This first PowerPoint series is long, but the next two, redox and acid base, are quite a bit shorter. So for the last part of this class, we were talking earlier about expectations. When I was a student, I attended a lot of seminars and advanced classes, and often I'd sit through the seminar and I wouldn't understand. I'd understand maybe 10% of what they were talking about. But I didn't really leave it at that, because what I'd do is right after the seminar, I'd go through the notes I took and try to fill in the blanks, and then I'd go and research and read some of their work if I was interested in the topic. And so it's the same thing with this. For some of you, this might be all reviews. For others, there might be some new stuff. But what you can do is, the last part, I'll leave some time. You can go through your notes and then see, maybe fill in some blanks. But if you can't remember what those blanks are, you can ask me. Like, I can help you fill in some of those question marks that you might have. And so let's use the last 15 minutes to, you can just review through and make sure you understand, because oftentimes what I don't do is I don't tell you, okay, this is, the main point of today's lecture. What I want you to do is I want you to come up with the main point or the main points of today's lecture based on what you think, not on what I tell you. And so what you should do is you should go back through and review the material and then see, what was I trying to get across here or get across there. So take some time and then just review, and then I normally have